That's good. That's going. Um, what we are going to talk about today with our last bit of new material is um, so the exam I just got the question, do we need to take the exam during the same time period as class, or can we take it anytime during the day? That's a great question. Thank you for asking. What I'm going to do for this first exam is it is going to open at 9:30 a.m. So before our class starts. And then I'm going to close it at 11 p.m. Um, typically, I like the exam to coincide with the time of our class. But just because there might be some technical issues and I don't want people to get super anxious about technical issues with taking the exam on Proctorio or with Proctorio, I'm going to extend that window. Sure. So we'll see how this goes. I think there's like 6 or 8 people who have not completed that quiz number 2, the one that's administered on Proctorio, because they're still encountering some technical issues. I don't really have in terms of a solution for that. The only solution that I really have is to get in contact with ITAC, and if they can't resolve the issue there, if you're in San Marcos, there's tons of computers in the library, or you could go to wherever you are, you could go to your public library and use a computer there, probably, provided that it has um, it provided that you have a webcam on that. So one thing that I want to make clear, and I actually had somebody email me this the other day. They said, "Oh, well, I did the quiz, but I got a 0 on it." Um, and I looked at that person's response, and they got the question wrong. So, um, you have the chance to look back at it's, if I remember that quiz correctly, there's only 2 options. Um, make another submission. You have up to 5 submissions for this one quiz. I think it's a program on Microsoft. I was having okay. So yeah, try different web browsers. I know that some people have said that Microsoft Edge worked for them. Other people have said Chrome worked for them. If you got a 0 on the quiz, it's probably because you got the question wrong. So I would try that again and see what happens. Okay, so, and I just based that on, I've seen other people's grades and they've gotten the full credit for it. Okay, so that's my plan for the exam. Now, just as a little bit of a review, when we previously talked about substances, we've talked about compounds, we've talked about elements, we've talked about atoms. Now, when we look at these 3 different images, which one of them represents an element? So, an element. It's not represents elements. Which one represents an element? So a single element. What we're looking for there is basically we've got these balls that are different colored or different colors. Well, these are 2 that are both green. Here is red and 2 whites. Okay. So which one of these do you think is, representing multiple different things and which one's representing one? And you're absolutely right. B is the correct answer. If we were asking about which represents a compound, a single compound, that would be A. And if we were looking for a mixture, well, then we'd be looking at C and alternatively, if I scribble this out, all these gray balls they're individual elements. But then whenever we add back in the green and white ones, that's where you have a compound mixed with these individual elements and you have a mixture. Okay, so what we've seen on the periodic table and what we can see on the periodic table, which I will post the version of the periodic table that's going to be on the exam later today. When you see a compound like this, what we've got, or when we see a symbol like this, you see basically 3 different things. 1 is a whole number. So what I mean by that is a whole number would be something that doesn't have a fraction. A whole number would be something like 1 or 2 or 77. A non-whole number, so 56.2, that is not a whole number. So on the periodic table, you will see one number that is a whole number. That is your atomic number. Will there be a physical study guide that we can print out for the exam? I believe that's on our Canvas page. Let me confirm. Yes, so I'm going to switch my screen for just a second. And actually, I'm going to switch it to view as a student so I can see what you guys see on the Canvas page. This right here, exam 1 study guide, that's your study guide for the exam. And so this highlights like lots of the high points, you know, questions that you can answer. Can you answer these questions? That's the study guide that I'm going to provide for y'all. So you can print that out if you want. Okay, now switching back. So this atomic number is represented as Z. That's and that is the number of, and I'm going to stop there and I'd like somebody to add to the chat. This is the number of what? And my hint is that it's a subatomic particle. Which subatomic particle? And remember, there's 3 different ones. There's protons, neutrons, and electrons. Okay. Neurons and protons. Protons is the correct answer. So this is your number of protons. Okay. Now, there's always going to be a symbol, a 2-letter symbol. Sometimes they're single letter, but typically it's going to be a 1 or 2-letter symbol. And that is going to be the element corresponding. So that would be the symbol for an element. Fe is the symbol for the element iron. Some of them have these kind of funky, like not funky necessarily. Sorry, I thought the same amount of neutrons and protons made the subatomic number. Okay, so that's actually our atomic mass, and I'll get back to that in just a second. So the chemical symbol is going to be, you know, for hydrogen, it's H. For helium, it's He. Sometimes, like with iron, this dates back to it's Latin. And it's like FeRr. A ferric substance is an iron substance. Okay, now the atomic mass. This is a number that is almost always going to be greater than your atomic number. And this is going to be basically, it's typically something that has a decimal. And this is what's known as the weighted average, or the average atomic mass. So these terms are so close. Atomic mass and atomic number. The atomic number is your number of protons. Christian added added a great question, and that is the atomic mass is going to be number of protons plus neutrons. Now, that's always something that seems a little bit odd and is confusing because, so, you know, if I said, all right, well, I've got 26 protons, does that mean that I have, let's see, that would be 29.845 neutrons? Huh? Can I have 0.845 neutrons? Well, that doesn't make much sense. And we've talked about this previously. We talked about a kind of phenomenon or an example of a substance. So like, what is something that has the same number of protons, but different number of neutrons? If you remember back, we talked about Oreo cookies. If you have like 3 different Oreo cookies, one weighs 12 grams, one weighs 13 grams, one weighs 16 grams. They're all Oreos, but they have different masses. They have different atomic masses. So if you have 2 things with the same number of protons, their atomic numbers are identical, but their atomic masses might be different. What are those 2 things commonly known as? And I'll give you a hint. It starts with an I. Isotopes. That's absolutely right. So you have different isotopes. Now, the atomic mass, your average atomic mass, takes into consideration all of the different isotopes. So if we had something like an isotope of iron, Fe, with 26 protons and 30 neutrons, the atomic mass of that is 56. And then a different isotope of iron that was still 26 protons because it has that same atomic number and 31 neutrons, it would have an atomic mass of 57. Now, whenever it comes to this average atomic mass that I'm looking at here, that takes into consideration all of the isotopes in existence. And it says, okay, well, 60% of them have a mass of 56. 40% of them have a mass of 57. And takes those up, adds all those up, and divides by their relative kind of abundance. So that's where that's coming from. Does anyone, okay, so, okay. So that's where average atomic mass is different from atomic mass. So the atomic mass, or the mass number, I'm sorry, your mass number is the number of protons plus neutrons. That's what your mass number is. Your atomic number is your number of protons. The atomic mass is the average of all of the isotopes of that particular element and their abundance of them. Okay, so there we go. Quick zoom poll here. Poll. Let's see what we got. This one. Okay. Which of the following is an element? We got 75 people here. I bet we can get 50 people to participate. We're at 35. We can give you about 15 more seconds. So that would be at about 40 total seconds. It's trending in one direction. Spoiler alert. We can get 5 more seconds. 2, 1, done. Okay, you're absolutely right. Or 74% of you are absolutely right. You recognize that that was a capital letter and a lowercase letter. That is one substance. Compare that to NO and CO. These are compounds because these are 2 different elements, carbon and oxygen pairing up to make one thing, nitrogen and oxygen pairing up to make one thing. These are both compounds. Now, just as a little bit of a suggestion for a test taking strategy, when you see things that they look pretty similar in their structure and their style to capital letters. Well, if you look at A and you say, oh, well, that one's right, well, then you have to say that B is also right because the structuring of that. And if A and B are correct, well, then A can't be correct and B can't be correct. Instead, they both have to be correct. And the only way that they are both correct is by answering D. So answer options A and B should be answer options that are less appealing than answer option D. And if you go through that and you're like, oh, well, I think A is right and I think B is right. Oh, but C is different. That should be a little bit of a hint to you and say, oh, okay, well, A and B are similar. If A is right, then B is right. And well, C is different. Why is that one different? If two of them are right and one is wrong, well, then I can't say that D is right. So just as a little bit of a test taking strategy whenever you see questions with answer options like this. Now I'm going to stop my share there. Okay, so when elements are arranged in order of their atomic numbers, their chemical and physical properties show what are known as periodic trends. Now we've talked about these a little bit. If you remember this grouping right here, does anyone remember, and it's small text here, but can anyone add to the chat what boron, silicon, germanium, arsenic, antimony, tellurium, and polonium are? They are in the P block and they are metalloids. Great response, Alex. Great job. Okay. What about these guys over here? They are typically going to be gases. They are non-metals. Great job. And then everything on basically the left-hand side of the periodic table. What are those? Metals. Perfect. Great job. Great job. Now, when we kind of dissect each one of these sections, we're going to see different things. We're going to see different kind of descriptions. In the middle, your transition metals. The far left, your alkali metals. If you remember last time, one of the things that we looked at was the reactivity of those alkali metals. Those alkali metals react violently in the presence of water. If you throw lithium into water, it basically starts sparking up and bubbling and producing gas. Sodium, same thing. Potassium is so dramatic that it kind of starts a little bit of a fire there, which is kind of crazy because I don't really think about water as something that starts on fire very often. Think about it evaporating, that's about it. Now, if we come back to atoms and molecules, discerning between an atom or, processing what's the difference between an atom and a molecule. A molecule is a group of atoms chemically bonded to one another. These colors, blue, red, black, and white, or these distinct kind of shadings, are pretty common. Oxygen is red. Hydrogen is white. So add to the chat, what is this compound right here? Count up the number of each species and H2O. Absolutely, it's water. Now, let's go with the other one, the other compound. What's that? CO2, carbon dioxide. Great job. Now, they can get a little bit more complicated than this. When you see something like this, oh man, where do you start? Okay, well, where we're going to start, and the way that I like to start, is basically identifying the substance or the element that's in the smallest amount. And these blue ones stand out to me. 1, 2, 3, 4. That's nitrogen. So I'm going to go ahead and write N4. Okay. And I always go with a subscript because that subscript indicates this many of that specific element. Now, next I go to red. Oxygen, oxygen. Okay, so I see O2. I'm making a compound. Now let me ask you, something that we brought up previously. Actually, no, we won't do that right now. So we've got N4O2. Does this compound have other elements? 100% it does. So we're going to go ahead and let's look at carbon, the black ones. 1, 2, 3, 4, 5, 6, 7, 8. C8. So we got N4O2C8. And now we're down to our hydrogens. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. H10. Now, this isn't a big part of our class, but the kind of norm whenever you're writing out a formula is to find the things that are farthest to the left on the periodic table. And the thing that's farthest to the left is going to be hydrogen. So I'm going to write that first. So I'm going to write H10, and then I'm going to go from left to right, and C8, because I'm going from the left to the right of the periodic table, C8 and 4, and O2. This is just rearranging. This is minor details, but I'm just kind of bringing up like what you might see on the exam. And that's your formula for caffeine. This is what caffeine looks like as a structural formula. Now, that was silly. I don't need that because this is just CO2. And actually, there's one thing to add here. We've got, and go ahead and answer, are these 3 distinct things? Like, are they a part of one big molecule? You're right. They are 3 distinct things. So how would we note that? Well, the way that we note that is we write our formula, H2O. H2O. How many of those molecules do we have? We've got 3. So we use a coefficient in front of H2O. So we say 3H2O. As opposed to what I wouldn't want anyone to do is to apply that 3 to any of you wouldn't say this is H6O3 because it is 3 H2Os. H6O3 is a completely different compound. So when we write something like this out and there's multiple of them, you indicate that with a coefficient. All right. Now, Zoom poll question. Oh, sorry, that's wrong. No, and poll. I need to go with, sorry about that, everyone. A, B, C, D, and E. C, D, and launch. All right. This one's going. Go ahead and answer. Okay, I'm gonna give about 5 more seconds. We got 58 out of 76 people. That's pretty good participation. And we're gonna stop right there. Okay. So if we look at the different answer options, one answer option. This is asking us how many hydrogens are in ibuprofen. Our ibuprofen structure, our formula is written right here. The coefficient is going to follow the elemental symbol. So the correct answer is 18. Now, I can see how B, 13 might be a pretty appealing answer because of the fact that, 13, 8. Okay, maybe. But test taking strategy and looking at this sort of formula, if you're using that rule, you want to check yourself and say, okay, well, I've got 13 hydrogens. Then that means there's 18 oxygens. Then there's 2 question marks? Well, the question mark is a part of the question, indicating what's the answer. So I think that makes B a less appealing answer option. If you answered A, I'm not exactly sure how you were applying this. There is a 2 in this formula. Why were you applying this 2 to the letter that's pretty far away from, or to the symbol that's pretty far away from it? And then answer option. So I think A is probably the least appealing answer option. E might be an even less appealing answer option. But then D, 33. Well, 33, you could come up with that by adding 13, 18. That would be 30, that would be 31. Plus 2 would be 33. That's the total number of atoms. And that's like a different question, which I think is a good question. But I would say, how many atoms are in ibuprofen? And the answer would be D. But that's not the question that I asked. I asked about how many hydrogens are present. So you always want to look for what is the element, and then what is the subscript. Okay. So 90% of y'all, great job. The others that just want to, process this a little bit more before you answer it, especially on a test. Now, with that in mind, let's say hypothetically that you had a question where that question was, let's say you had a question that was, and actually, no, we can jog back for a second. When we looked at 3H2O, there are 3 water molecules. My question for you is, and add to the chat, if I say 3 H2Os, how many hydrogens are there? 6. Okay. How many oxygens? 3. Great. Great. Fantastic. Okay. Great. Now, this right here is our last question. Carefully answer. Do not answer it yet. I've said do not answer it yet. And somebody answered it immediately. Okay, we're going to stop this poll. We're going to redo this one. Okay. Look at this question. Do not answer it in the chat. Wait for me to repost this one. This is asking us how many hydrogens are in this expression. C13H18O2. I want to get 100% correct on this one. I know we can do it. Are you ready? You're ready. Okay, I'm going to give you about 10 more seconds. We got 54 participants. I think we can get up to 56. Okay, we got 56, 57. I think we can get up to 60. 3 more. Two more, one more. Okay, I'm stopping right there because the last person to respond had the correct answer. Our correct answer here is E. Why is it E? This question asked us about hydrogens. Now, when we were asking about hydrogens, in this one thing, which what we just did, we said that there are 18 hydrogens, but we've got to take into consideration the coefficient. So we have 18. It's almost like you have C13, H18, O2. Then you've got C13, H18. Exactly, you multiply it. C13, H18, O2. So that's effectively what we've got. How many hydrogens are here? 18. How many are here? 18 more. How many? 18 more. So this is a total of 18 plus 18 plus 18 is 54. That's how we arrive at answer option E. Now, we had a total of 8 people who marked B. They're right with the subscript, but they forgot that coefficient. You have to remember that coefficient because whenever I say something like are in the expression 3 C38 or C13 H18 O2, I'm meaning there's 3 of them. And I hope that this displaying this was helpful to illustrate there are 3 of them. In terms of answer option A, which there's one person who marked that. Remember, it's the coefficient or it's the subscript that follows the symbol, follows the letter. Then there was 2 people who marked 21. And I think that what they must have done was they just said, okay, well, 3, I'm just going to add that 3 to 18. That's how I get to 21. You're not going to add it because you've got 3 distinct things. So that's how we get to the 54. Then for 39, effectively, it looks like what you did was you multiplied, but you made the mistake of using the wrong subscript. So you always have to use the subscript that follows and the coefficient. Because whenever we asked, when we looked at water, how many hydrogens were there? Every single person said 6. Every single person said, how many oxygens are there? Well, there's 3. Everyone got that right, and that's great. And I think that to me, or sorry, what that translates to me is that when you draw it out, it helps. Drawing this out might be a little tricky, but you could write that symbol out, or you could write that formula out, and you could say, okay, well, in this one, there's 13 carbons, 13 carbons, 13 carbons. So we're looking at a total of 39 carbons. I think that might be a really good strategy to use. And whenever you're taking your exam on Monday, you can use scratch paper. So I would definitely make a point to, work through a problem like this and work through it like slowly and deliberately. I gave an exam for my Chem 1330 class. That's a class that it lasts 80 minutes. And I've looked at the grades, and there is an amazing trend. And that was, I'm going to stop my share. The people who took longer to answer the exam questions scored higher. There were people who they took 8 minutes to do the exam, and it was a 25 question exam. So if you think about that, 25 questions, 8 minutes. What that means is that they answered about 3 questions a minute. And that means that, let's say there was a question like this. That means they took about 20 seconds to answer this question. Okay. Well, if it takes 20 seconds to answer this question, either you know it really well or you don't know it well at all. They had 80 minutes to do the exam. You guys have an exam that will be about 20 to 25 questions. So you'll have about 2 minutes roughly at least 2 minutes per question. So you have some time where you can process it and you can say, okay, what am I being asked about? Okay, I'm being asked about hydrogen. All right, great. Where is hydrogen right here? Oh, hydrogen is the H. Okay. I haven't even read the question. I just picked up hydrogen and that symbol. Now, if I take it a step further and I read the complete question, how many hydrogens are in the expression 3H18? Okay, so this is my expression. That 3 is going to come into play. So let's see it. H18. I think that I'm going to go with 54. How long did that take me to answer that? I think that it's fair to say it took like a minute for me to like say that all aloud. Um, what I really just want to stress is I saw this here whenever I was asking this question. People who, the first, I think it took like 12 seconds for somebody to come up with the right answer, and then about 12 seconds to come up with the wrong answer. And then as we spent about 20 to 30 more seconds, the number of right answers like skyrocketed. The number of wrong answers stayed low. So my point in all of this is that the longer that you take, the more, patience that you grant yourself with the exam, the more likely I think that it is that you're going to get it right because you're going to process the information a little bit more. Okay. That's where I want to stop. So this is the end of our new material. So this is it. On Friday during class, we will be reviewing. So we'll be working through that exam study guide. And so we'll be going through that. I'll be answering questions. I should have the exam written by then. So I'll say it's 20 questions or 22 questions or whatever it is. And then what the total points of those are. And I'll probably answer some questions about grading because people always have questions about grading. And, basically like everyone always has the question of like, what if I don't do as well as I expect? How can I improve? And so we can talk about that. I'm going to stop my recording right now.